Functional programming languages. Explained in simple words. What does functional programming language mean? A functional programming language is a programming language that focuses on functions to solve problems. Instead of changing data step by step, functional programming uses functions to process data and produce results. In simple words, functional programming equals solving problems using functions. It means functional programming languages use functions as the main building blocks. Avoid changing data frequently. Focus on calculations and transformations. Treat functions like values. Emphasize clean and predictable code. So, functional programming equals function-based problem solving. Example idea. Imagine you want to add numbers in a list. Instead of writing many steps and loops, functional programming allows you to use functions that directly process the data. Example idea. Input. Numbers list means 1, 2, 3, 4. Function processes list. Output 10. The function simply transforms the input into output. Key concepts in functional programming. Functional languages focus on several important concepts. Pure functions. A pure function always produces the same output for the same input. Example idea. Input 5. Output 25. No hidden changes occur. Immutability. Data does not change after it is created. Instead of modifying data, functional programming creates new data. Example idea. Instead of changing a list, the program creates a new list with changes. Higher order functions. Functions can accept other functions as input or return functions as output. Example idea. A function that applies another function to a list of values. Recursion. Functional programming often uses recursion instead of loops. Recursion means a function calling itself to solve a problem. Popular functional programming languages. Some programming languages designed for functional programming include Haskell, Lisp, Scala, F#, Erlang. Some modern languages support functional features as well. Examples: Python, JavaScript, Java. Real-life uses of functional programming. Functional programming is widely used in data processing systems, financial systems, artificial intelligence, parallel computing, distributed systems. These systems benefit from predictable and safe code execution. Why functional programming matters. Functional programming helps developers create cleaner code, predictable programs, safer data handling, easier testing. Because functions do not change data unexpectedly, programs become more reliable. Advantages of functional programming. Easier to test and debug. Reduces side effects. Supports parallel computing. Encourages reusable code. Makes programs more predictable. Disadvantages. Crossmark can be difficult for beginners. Crossmark recursion may be harder to understand than loops. Crossmark sometimes less intuitive for certain problems. Crossmark performance issues in some cases. Comparison with other programming styles. Procedural programming uses step-by-step instructions. Object-oriented programming uses objects and classes. Functional programming uses functions to process data. So, functional programming focuses mainly on functions. Common beginner misconceptions. Beginners often think functional programming means only using functions. Functional languages cannot handle large systems. Functional programming replaces other programming styles. But actually, functional programming is another powerful way to solve problems. Real-life analogy. Functional programming is like a mathematical formula triangle ruler. Example: f x equals x plus 2. If x equals 5, result 7. The function always produces the same output for the same input. This is how functional programming works. Important point. Functional programming focuses on functions, data transformation, predictable outputs, minimal side effects. This approach helps developers build reliable and maintainable software. Simple definition. Functional programming languages are languages that use functions as the main way to process data and solve problems. Final summary. Functional programming languages. Checkmark use functions as the main structure. Checkmark avoid changing data unnecessarily. Checkmark focus on predictable outputs. Checkmark encourage reusable and clean code. Checkmark support advanced computing systems. Without functional programming concepts, cross-mark programs may become harder to maintain. With functional programming, checkmark clean code structure. Checkmark reliable program behavior. Checkmark better scalability. Checkmark easier debugging. Functional programming is an important paradigm in modern software development.